Welcome. In this video, I'm going to demonstrate how to find the resultant force. That is, we're going to see an application of vectors. So please take a moment and read this problem independently. Okay, so let's get started. We're told that this car has two forces acting on it, a horizontal force in this direction of 300 pounds, and this 150-pound force, which makes an angle of 15 degrees from the horizontal. So let's talk about what our goals are. The first goal is, what is the sum of these vectors? That is, what is the resultant force? Actually, before we can even express this goal, we need to name these. Let's name this vector W. Let's name this vector V. So our goal is W plus V. And then that's one goal. So one goal is this sum. And the second goal is to find the angle of that sum. So before we can do either of them, let's go ahead and figure out what W and V equal. Let's start with W. Now, W, you can find its x component using right triangle trigonometry. So if I sketch out a little aside triangle, this is W. Actually, this is the magnitude of W, which is equal to 150. I know that the x component, using right triangle trigonometry, is given by 150 times cosine of 15 degrees. That equals x, since cosine of 15 degrees equals x over 150. Similarly, the y component is 150 times sine of 15 degrees. This is the y component here. Okay, now what about v? Well, v, we could draw a triangle. It's flat, so I know that the x component, at least the magnitude of x, the x component is just going to be 300 times a cosine of 0 degrees, since this is on the horizontal, and the sine is going to be 300 sine of 0 degrees, since again, this is horizontal. And by the way, this is overkill. After this example, you'll see how much easier it is to actually find the vector components for some, quadrantal angle. So 0 degrees, 90 degrees, etc. But for now, I'm going to show you kind of step by step how to do that. So this is just 300 times 1, and sine of 0 is 0, so that's just 0. And you could have easily just observed that this length is 300 and it has no vertical part, so there's no vertical component, so you can just let the y component be 0. Okay, so now let's tackle goal 1. Goal 1, that is the sum W plus V, that's equal to 300 plus 150 cosine of 15 degrees. So all I did was add the two x components. And for the y components, I have 0 plus 150 sine of 15 degrees. So that's just 150 sine of 15 degrees. Please pull out a calculator and work this out. So for your x component, you have 444.9. And the y component, we get 38.8. Now, for goal 2, we want to find the angle made by this resultant vector. So it'll help us if we visualize this vector. So let's visualize this vector in pink. And I'm going to do the typical vector addition thing, where I will, let's say I'm going to mark the v vector right here. And I'm going to use my handy dandy technology to go ahead and move the tail, and the tail is this part, to the tip of this one. So remember, this is a V, and this is W. Oh, I am missing my the arrow there. So let's go ahead and connect these. And when we connect them, we end up with, there we are. That's good enough. So this here is W plus V. And so when we say we want the angle, we want this angle from the horizontal. I'm going to mark this as theta. So since this picture is a little tricky to see, let's go ahead and resketch it right here. So I'm going to go ahead and sketch V in the its coordinating color. And I'm going to exaggerate this. So I'm going to draw this so it looks much steeper than it actually is, just so we can get a better idea of what's happening. Well, there we are. There's an exaggerated version of V plus W. And then here is V. Now V we don't need too much of. I'm just kind of including it here so we see where we are in the picture. What I really want to do is I want to continue this until I make a right triangle. Okay, so now that I've continued this, I'm going to go ahead and erase V. And I know that this is the x component of W plus V, and this is the y component of W plus V. And here is theta, our unknown angle, in the same color. So we can coordinate. So again, think back to right triangle trigonometry. The tangent of this angle is equal to y over x. That tells me tangent of theta is equal to the y component of 38.8 divided by 444.9. So that is, we have tangent, oh, excuse me, I should start with theta. Theta equals tangent inverse of 38.8 divided by 444.9, and that's about 5 degrees. If you're getting a different answer for all of these, and your calculator is probably in radian mode. Okay, so let's just make sure we are done. We found the resultant force here, which I called 1. Oh, we forgot the magnitude. So I'll call that 3, and the direction angle, we found that. So this is 2. Let's quickly take care of 3. And 3 isn't too difficult. 3 is the magnitude, so let's add that here. The magnitude of this vector. And let's go ahead and squish that in right there. So the magnitude is really just the square root of 444.9 squared plus 38.8 squared, and that will get you approximately 446.6 pounds. I hope you found this video helpful.